Hello everyone. In today's lesson, we're going to look at the 10 theorems of a circle. So this lesson is very much necessary for those who are preparing for WAEC exams. All right, let's dive in. Theorem number 1. The line which joins the center of a circle to the midpoint of a chord forms a right angle with the chord. You have a circle. Now, a line which join the midpoint. Now, let's take this. This is our chord. And if we take this point to be the midpoint of the chord, let's label it maybe E, or let's label it F. This is the midpoint of the chord. And if we take this point here to be the center of this very circle, let's label the center C. All right. Now, this first theorem is saying that the line will join the center of a circle to the midpoint of a chord. This is the line. It runs from the center of the circle to the midpoint of a chord. And we say that this very line will form a right angle. So this is a right angle here. So remember that a right angle has a value which is equal to 90 degrees. So this means that 90 degrees is formed there. So this is basically what the first theorem is all about. A line which joins the midpoint of a chord from the center of a circle will form a right angle. So this is theorem number 1. Let's look at theorem number 2. The second theorem says that equal chords of a circle are equal in distance from the center of the circle. All right. Now you have a circle. This is a circle. And we're taking this to be the center of this very circle. We can label it C. Okay, and let's say you have a chord that is running this way. You have another chord which is running this way. Now, the law is saying that the equal chords of a circle are equal in distance from the center of the circle. This is the center of the circle. If we assume that chord AB is equal to chord CD, all right, okay, let's call this E, all right, since we already labeled here C. Now, if we assume that chord AB is equal to chord ED, now it also means that their distance from the center will be equal. So let's label this point here F, and let's label this point here, let's call it G. All right, so this law is basically telling us that if you have a chord like we have here, this chord and this very chord, which are equal to each other, then their distance from the center of the circle will also be equal. So that means that since chord AB is equal to chord ED, then CF will also be equal to CG. So this is what the law is saying. Now, we can also put this law the other way, that when you have a chord, or when you have chords which are equal in distance from the center of the circle, then those two chords will be equal to each other. So that is the law. I repeat again, equal chords of a circle are equal in distance from the center of the circle. When you have two chords which are equal in length, then their distance from the center of the circle will also be equal. Likewise, if you have chords which are equal in distance from the center of the circle, then those chords will be equal to each other. I think this law is okay. We're good to go with this law. Now let's dive into the next law, which is theory number 3. Okay, theory number 3. Now theory number 3, look at it before us. And what does it state? It states that the angle subtended by an arc of a circle at the center of the circle is twice the angle it subtends at any other point on the circumference. Okay, now look at this. You have a circle, all right? This is a circle. Now, what is this law? Let's take this point to be the center of this circle. Now, if you have an arc, all right, let's take this. Let me take this is our radius, this is an arc, and this arc subtends an angle at any point on the circumference. Now let me roll this so that an angle will be formed at the circumference. So an angle is formed here at the circumference. So let's call this very angle x. All right. Now this is the center of the circle. Of course, an angle is also formed here. So let me call this very angle theta. All right. Now the angle that is formed here, I think this is a little bit dim. Let me use this pen. Please, this is x. We have x that is formed here, all right, and the angle that is formed here is we'll call it theta. That's the angle that is formed at the center is theta. Okay, so what is this law saying? The law is saying that the angle that is formed at the center is going to be 2 times the angle that is formed at the circumference. It means that the angle theta, which is formed at the center, is going to be equal to twice, that is 2 times the angle at the circumference, 2x. Yes, let me read the law again. It says the angle subtended by an arc of a circle at the center of the circle is twice, that is 2 times, the angle it subtends at any other point on the circumference. Now, it also means that the angle that is subtended at the circumference is going to be half the angle at the center. So it means that x is going to be equal to theta over 2. All right. So let's now move on to the next theorem, which is theorem number 4. All right. Theorem number 4. What does it state? Theorem number 4 states that the angle in a semicircle is a right angle. Okay, this is, I think, a very simple theorem. You have a circle, all right. Now let's get our semicircle. If this is the center of the circle and I have a line dividing the circle into 2, so means this part, this is a semicircle, this part is also a semicircle, and this is our diameter, dividing the circle into 2. Now what is this law saying? The law is saying that the angle in a semicircle is a right angle. Remember that a right angle has a value. A right angle has a value that is 90 degrees. So the angle in a semicircle, this is one of the semicircle, this is one of the semicircles. So let's form an angle in the semicircle. Now let me form an angle here. Let me take an angle is formed here. Okay. Now if I call this very angle theta, let me call this angle theta. Now the law is saying that this very angle theta is going to be equal to 90 degrees. Why is it so? Because it is formed in a semicircle. Likewise, if I decide to form the angle somewhere here, this is also another part of a semicircle. All right, if I decide to consider this is a semicircle, the angle that is going to be formed here, if I call it y, it's also going to be that y is going to be 90 degrees. So angle formed in a semicircle will be 90 degrees. Okay, theorem number 5. Okay, theorem number 5, look at it before us. Theorem number 5, I hope this is clear. All right, let me place it properly. Now this is theorem number 5, and what does it state? It says that angles in the same segment are equal. Angles in the same segment are equal. Now the question is, what then is a segment? What is a segment? Remember that a segment is bounded by a chord, and and an arc. Right, so when you have a circle like this, segment is that part of the circle that is bounded by an arc and a chord. So this is the segment. Now the law is saying that angles in the same segment are equal. Take for instance, you have a circle. Okay, let me draw a circle. All right, this is fine. Okay, now this is our chord. All right, now the law is saying that this is a segment. Remember, this is a segment, this part is a segment, and this part is also a segment. So this is a major segment and this is a minor segment. Major segment, minor segment. Now if we have angles forming in the major segment, which is the same segment, take for instance I form an angle here. All right, let me form an angle here at any point on the circumference. Okay, then let me also form another angle. Okay, let me form another angle here. Let me put it, let it run this way. Good. Now an angle is formed at this very point. Let's call the angle that is formed here y. All right, y. And the angle that is formed here, can we take it to be x? Okay, let's call it x. This angle here is x. Please, this angle here, I believe this is clear, we can see it clearly. The angle that is formed here is y. Now what is this law saying? The law is saying that angles in the same segment, this is one major segment. The whole of this is one segment. So the angle formed in the same segment are going to be equal. It means that x will be equal to y. That's just what it means. Why? Because angles formed in the same segment are equal. So x will be equal to y. Are they in the same segment? X and y, are they in the same segment? Yes, they are in the major segment. If I label these here A, B, C, and D, you'll find out that x and y are in these very segments. All right, A, C, all right, let me say A, C, D, B. All right, A, C, D, B. So x and y are in the segment A, C, D, B, this very major segment. So because of that, following the law, these two angles will be equal to each other. All right, so let's move on to the next theorem. The next theorem, which is theorem number 6. What does it state? What does it state? Now look at it. The theorem states that the sum of the opposite angles of a cyclic quadrilateral is 180 degrees. Okay, I said that the law could also be stated this way, that angles in opposite segments of a cyclic quadrilateral are supplementary. Take note that two angles are said to be supplementary when they are added up. It gives you 180. So if you have angle A plus angle B, and you add them up and it sums up to 180. So we say that angle A and B are supplementary angles. All right. Now another thing you need to find out here is what a cyclic quadrilateral is. Cyclic quadrilateral. Now a cyclic quadrilateral is basically four-sided plane shape, which is bounded by a circle. All right, let's take for instance you have a circle. We have a circle. All right, this is a circle. I want to inscribe a cyclic quadrilateral in this very circle. Okay, so I can have a four-sided shape. Let's say I have one here. Okay, and I have another one running this way, and remember it's four-sided. I can also have, this is 1, 2. All right, I can also have another one running this way. All right, then let me roll it up down here so it to be four-sided. So a cyclic quadrilateral is a four-sided plane shape, all right, that has a circle joining the vertices. These are the vertices or the corners of the shape that is inside the quadrilateral, that is inside the circle. you have a circle that is joining the vertices or the corners. So we'll call this a cyclic quadrilateral. So what is this law saying? The law is saying that the sum of the opposite angles. Now let's take, for instance, you have, of course, you have angles forming here. Angles are formed here. Angles are formed there. Okay. Now let's label this angle here, X. Let's call this X. And let's label the angle formed here to be Y. Okay. And let's label this one P. Okay. Let's label this P. And let's label this one theta. Let's label this theta. Okay. Now, this law is saying that the sum of the opposite angles of a cyclic quadrilateral is 180. Now, x is opposite to y and theta is opposite to p. They are opposite to each other. So it means that x plus y is going to be equal to 180. They will be supplementary. And it also means that theta plus p is equal to 180 degrees. So take note, this is what Theorem 6 is saying, that when you have a cyclic quadrilateral, that the sum of the opposite angle is going to be equal to 180 degrees. These are opposite angles. This is opposite to this very angle. So their sum is equal to 180 degrees. Okay, we're going to apply all of this in problems in subsequent videos. Okay, but let's now move to the next theorem, which is theorem 7. All right. Okay, this is it before us. Theorem 7. Okay, now what does theorem 7 states? Now theorem 7 is saying that the exterior angle of a cyclic quadrilateral is, let me place this properly, the exterior angle of a cyclic quadrilateral is equal to the opposite interior angles. The exterior angle of a cyclic quadrilateral, which means here we also have a cyclic quadrilateral. So we have a circle and you have a cyclic quadrilateral. Let me say you have something like this. Another one is going this way. Okay. And let me say this is going this way. And I have another line joining this part. Okay. Let me just extend it out so we can have an exterior angle. All right. So we want an exterior angle. Of course, exterior angle is an external angle. So let an exterior angle be formed here. An angle is formed here. And I'm going to label this angle X. Let me label it X. So this is the exterior angle. X is the exterior angle here. So the exterior angle of a cyclic quadrilateral is equal to the opposite interior angles. Okay, now, of course, we know that angle is formed here. And let me label this very angle here Y. Okay, let me label this Y. All right. Now, if we go by this, it means that X is going to be equal to Y. Why is it so? This is because this very angle is opposite to this. Now, if I am to rule a line, okay, you find out that this is running this way. Okay, this is running this way. So X is opposite to this. This very angle is opposite to this very side. And this very angle is opposite to this very side. Can you see? So the theorem now is saying that the exterior angle, which is X, of a cyclic quadrilateral is equal to the opposite interior angle. So Y is going to be opposite to this very angle. As you can see, this is opposite, directly opposite to it. So it means that the exterior angle X is going to be equal to the opposite interior angle, which is Y. So this is what the theorem is telling us. All right. I believe this is clear to us. Now, can we now move to the next theorem? That is theorem 8. Theorem 8, what does it state? Theorem 8 is before us. I believe this is clear. You can see clearly. All right. Okay. So what does it state? It states that a tangent to a circle is perpendicular to the radius at the point of contact. At the point of contact, what is a tangent? What is a tangent line? A tangent to a circle is a straight line which touches a circle externally. Now you have a circle, all right. Now let's say a tangent, this is this very line that touches this very circle, we call it tangent. This is a tangent line. It touches the circle at one point, so this is a tangent line. Okay, now what is the law saying? That a tangent to a circle is perpendicular to the radius at the point of contact. Now this is the center of the circle. Of course, we know that the radius is a line that runs from the center of the circle to any point on the circumference. So this is the radius of the circle. Now, and the law is saying that if this happens at the point of contact, that is going to be perpendicular. Perpendicular means an angle of 90 degrees will be formed. So this is going to be 90 degrees. Yes, remember, when you have two lines that are perpendicular to each other, it means that angle 90 degrees, that the right angle, is formed. So this is basically what the law is saying, that when you have a tangent, all right, tangent to the radius, that at the point of contact is going to be what? 90 degrees, that is perpendicular. I believe this theorem too is we are good to go with this very theorem. So if that is the case, then let's look at the next theorem, which is theorem number 9. Theorem number 9. Okay. Circle theorem number 9. With these theorems, you can basically solve most of the problems in some circle theorem that comes out in WAEC. All right. This is theorem number 9. What does it state? Says that two tangents drawn to a circle from an external point, take note of this external point, are equal in length and subtend equal angles at the center. Okay, let's visualize this in a circle. You have a circle, all right. Okay, and the two tangents. Of course, we know what tangent is now. A line that touches the circle at one point. Okay, let's take this to be our tangent. All right, then you have another tangent. So please, this is a straight line. Please let it be as straight as possible. And you have another tangent. Let's say this one is running this way, and this is the point where they meet. Okay, now this is two tangents drawn to a circle from an external point. This is external point. Let's label here B. This is our external point. You have them running, meeting this point. These are the two tangents, are equal in length, meaning that this line or this line and this line are equal in length. So this tangent will be equal to this very tangent. So if I call this C, label here C, and I label here D, it means that line BD, all right, is going to be equal to line BC, following the law. So two tangents, okay, two tangents drawn to a circle from an external point are equal in length and subtend equal angles at the center. It's very important. Now, if I take here to be the center of this very circle, okay, so let me label the center to be P. All right. Now, let me take, this is the radius of this circle to this very point, and this is the radius of the circle also. All right. So of course we know that an angle is formed there. Okay, let me divide this. All right, now an angle is formed there. Let me call this X. Also an angle is formed there. Let me call this Y. All right, of course, following theorem 8 that we looked at earlier, it means that a right angle is formed there. Remember, this is going to be 90 degrees. Remember that when a tangent, all right, touches at the point of contact with a radius, that it is perpendicular. So perpendicular angle is formed there, which is a right angle rather, is formed there, and it's going to be 90 degrees. Now What is this theorem telling us? That two tangents drawn to a circle from an external point, two tangents from an external point are equal in length. BD is equal to BC, are equal in length, and subtend equal angles at the center, meaning that the angles at the center X is going to be equal to Y. Yes, because this very tangent subtends angle X at the center, and this very tangent BC also subtends angle Y at the center. And following the law, we say they're going to be equal, the angles will be equal, hence X will be equal to Y. All right. So with this, we can carry out lots of calculations, All right, then let's move to the last theorem. The last theorem, all right, which is theorem 10. All right, this is it. And what does it state? Theorem 10 says that the angle between a tangent to a circle and a chord at the point of contact is equal to the angle in the alternate segment. Okay, now you have a circle. Remember the angle between a tangent to a circle. So let me draw a circle and a tangent to a circle. And this is the tangent to this very circle. All right, let me label this point A and label point B, and let me call this point D. Okay, and I want to inscribe, okay, let me say you have a chord running this way, you have another chord running this way, and we have another chord running this way. Okay, so an angle is subtended here and another angle is also subtended here. All right, so now let's call this very angle subtended here X. The angle at this point, let's call it X, and the angle at this point, let's call it angle Y. Okay, so an angle is also formed here, of course. Let's call this very angle A, and an angle is also formed there. Let's call this angle B. All right, so the law again, what is it saying? That the angle between a tangent to a circle, this is it, and the angle between tangent to a circle and a chord, tangent to a circle and a chord, X is the angle between tangent to a circle, this is the tangent to the circle, and this very chord. That this very angle will be equal to the angle in the alternate segment. Is basic. Another way we can put it, when it comes to this alternate segment, we can say the opposite angle. In this case, this very angle A will be equal to this very angle here. Yes, this is angled. Now, this very segment here is opposite. See these segments? They are opposite to this very segment. So the angle that is formed here will be equal to the angle that is formed between this very chord and this very tangent. So it means that X will be equal to A. Yes, A is the angle in the alternate segment, meaning that it is facing it. All right, alternate segment, and it also means that this very angle here Y will be equal to the angle here. Yes, following the law, the angle between a tangent to a circle and a chord, this is it. Y is the angle between tangent to a circle and a chord. It will be equal to the angle in the alternate segment. This is facing it, this is directly opposite to it. So this is the alternate segment here. These segments are alternate to this very segment here. Okay, so it then follows, it means that the external angle, or rather the angle between the chord and the tangent, is going to be equal to B. So this is basically what the law is all about. All right, so in our subsequent videos, we'll go through problems. We're going to apply all of these laws we've looked at, theorem 1, theorem 2, theorem 3, up to the 10th theorem. We're going to apply them in real WAEC problems. So I would like you to look at subsequent videos. All right, guys, bye for now. Love you all.